Okay, this is exercise number 7, and it says solve the following differential equation and find the particular solution if an initial condition is given. But, well, we don't have an initial condition. Okay, first we have that the way to solve the linear non-homogeneous equation is with this, that is the derivative of y plus f of x multiplied by y of x equals r of x. Okay, with this we can assume that f of x equals -2 as shown in the first equation, and r equals to x. Okay, with this we can go on the solution. So we have that cb of x equals the constant c times e raised to the minus the integration the integration of f of x times dx. We already have the function of x, so we can get the b. So v of x equals e raised to the minus integration of f of x dx. So we know that b of x equals e minus the integration of -2 times dx. So we have that b of x equals to e raised to the 2 times x. Okay, so cb of x equals the constant c times e raised to the 2x. Well, with this we can go on to get the letter u, and we know that u equals to the integration of r divided by v. So we already have the two letters. We have the r that equals to x, and we have the v that equals to e raised to x. Okay, and that equals to the integration of x times e raised to the -2x. Yes, and we know that all of that, sorry, the dx is missing. Sorry, all of that is multiplied by dx. We know that all of that equals, well, using the integration by parts or integrating by parts, we know that this equals -x times e raised to the -2x divided by 2 minus e raised -2x divided by 4 plus the constant. And with this all we have to do is make the last equation, that is y equals u times v. And well, we have that u equals to the thing that we already have, and well, plus the constant. If we multiply that equation, we have that the e transforms into a 1, because 2x minus 2x equals 0, so e raised to the 0 equals 1. So plus c times e raised to the 2x. Okay, and that's the solution. For the second example, we have this equation. Well, we're going to solve this example. First, we need to sort it so it looks like the non-homogeneous linear equation. So f of x equals -x, like we know, and r of x equals to the x squared times e raised x raised 2 over 2. Okay, so we can go on. We know that cv of x equals to the c e raised minus the integration of f of x dx. So we know that c e minus the integration of -x dx equals to the constant times e x raised to over another 2. And well, v of x equals to e, v equals to the same thing without the c, without the constant. Now we can go on and get the u that equals to the integration of r over v. Okay, so we have the r and we have the v. We make the substitution of it. That is that equation. Sorry, the e raised to the x squared over 2 transforms into a 1 because it's multiplied and then divided. We only have the x squared, so we integrate it, and we have x cubed over 3 plus the constant equals u. So we have the last equation, that is y equals u times v. All of that equals x cubed times e raised x squared over 2 over 3 plus the constant multiplied with the e raised x squared over 2. And now that's our solution. And the last example, the third equation. Okay, we are going to do exactly the same thing that we did. So we got the f of x and the r of x. We're going to get the cb of x, and the integration equals to the inverse tangent of x. And we have already to get the u. There is the integration of r over v. That's more understandable. And then we can have the y equals u times b. So we get the constant multiplied by e inverse raised inverse tangent of x minus the 1. That's the solution of the last equation, differential equation.